Okay, I've got the answer key here. I'm going to talk you through it very quickly. Number one, I would memorize or just learn these three simple rules for exponents. Very, very handy. A negative exponent is the same as 1 over that x to the positive exponent. 1 over any number is like a root number, so the bottom number of a fraction is the root and the top number is the exponent. You can write this with the m outside or inside as you need to for convenience. Alright, so the answers are very simply flip that 100 and you get 1 over 100, which is 0.01. You can write it either way. You've got 1 over the square root. That's what that 1/2 is the square root. The negative flips it upside down and you take the square root of 121, you get 11. Please write it as a fraction, not a decimal. It's much simpler. Negative 3/4 is the exponent, so again you take 1/64, you flip it. 64 over an invisible 1, you're taking the 4th root of it, but you're raising it to the 3rd. Here, because 64 is one of your special numbers, it's 2 to the 6th, it's actually easier to break that down to 2 to the 6th than raise that to the 3rd. That's what I've done over here. 6 times 3 is 18. When you're taking the 4th root of something to the 18th power, you're pulling out groups of 4. Well, you can take out 4 groups of 4. So out comes 2 to the 4th. What's left behind is your 2 remaining 2's. That's 2 times 2 is 4. So you just write the 4th root of 4. You can write it this way, or if you want to write 2 to the 4th, that's 16 with 4 radical 4. You can do it that way. One of the tests will probably be a little bit simpler, but that's the rule. For this one here, just be very, very mindful of the negative exponents. They're like little elevators. They take you up a floor or down a floor, and you simplify that and then just cancel your x's and your y's as your normal rules of division with exponents. With this next problem, you're investing $2,000. You're going to do this 3 ways. You can just simply take and type this in, 2,000, and you're going to raise that, you're going to multiply that times 1 plus 0.15, so that's 1.15. And caret that to the 8th power because it's 8 years, and you get $6,118. And you can just go to, I guess, the nearest 05 cents if you want to be fussy, but I'm not going to worry about pennies. And then for the second one, it's going to be 2,000, and this time 1 plus, and then 0.15 divided by 365 days in the year. You can do 0.25 even if you want to be super fancy and get in the leap day or whatever every 4 years, quarter of a day. But then you caret and put this in parentheses, 365 and times 8, I think it is 8 years, yep. And you hit enter, and now we get 6,638.60 cents. All right, and then finally we've got the version that is the continuously growing one. So that's PERT. So I have 2,000, and then times second. The ln key gives you 0.15 times 8, close parentheses, and that's 6640 to the 23 cents. Okay? So now to do this final problem, how long will it take for the money? Quadruple. I've already typed it in there, and I've got my graph. It's just the 2 equations, the continuous growth equation, and then I've graphed y equals 8,000. And you can see there where it is. My window is set very sensibly to be up to 20 years and up to $10,000. And I just want to see where they intersect. Second trace will give me the intersect option number 5. Enter, enter, enter. And it is after 9.24 years. Okay? And I'll let you work out how many months and days it is. But decimal years is okay. All right? Then finally, we are just solving this cube root equation, and I think that the stuff I've posted is pretty clear. You just go through the steps of solving by switching the f of x out to y, then switching the x and y, and then solving for the y, just using your good algebra skills. Just don't forget to write the inverse in the appropriate form, okay? Then when you graph the original function in dark and the inverse in dotted, you'll see that they are always the mirror image reflected over that x equals y line. All right? Very good.